Welcome to our lesson on direct, joint, and inverse variation. In this lesson, you will learn how to identify and to solve direct, inverse, and joint variation equations. And you're going to learn how to write those variation equations based on things that are happening in the real world. So one of the things you're going to see in all of the equations is this letter K. And in variation equations, that letter K is called the constant of variation. Now remember, a constant is a number that doesn't change, so it just represents some constant value. In direct variation, y varies directly with x, so the equation is y equals k times x, where k is that constant of variation. If we solve this equation for k by dividing both sides by x, we get k is equal to y over x. Now the thing you'll notice in this direct variation equation, if I let x get bigger, if x increases in this side of the equation, then in order for that to be a constant, y would have to do the exact same thing. Y follows x, so if x goes up, y goes up, and if x goes down, y goes down. That is called a direct variation. In inverse variation is the opposite of direct variation. K is over x, so you'll notice that if we solve for k, multiplying both sides by x, we have the constant is the product of the two numbers x and y. And if x goes, if x goes up in an inverse variation situation, y does the opposite and goes down. So direct and inverse variation are completely the opposite. And then in joint variation, the way to recognize joint variation problems is you will have three variables. So you'll have a y, an x, and a z. And those might be different letters representing different things, but you will have three things that are changing. And your constant of variation then is equal to y divided by xz. So if we let x go up, then y also has to go up, but z will go down. If we have z going up, then y will also go up, but x will go down. So you'll notice that x and y vary directly, but x and z vary inversely. And you can notice that because they're in the denominator. So here are some graphs of direct and inverse variation. On the left we have direct variation, and three things that you should notice about direct variation graphs. The first thing is it always graphs as a line. It's always a linear situation, and it always goes through the origin. If you have a graph where it goes through any other point other than the origin as far as your y-intercept, then it is not a direct variation equation. And lastly, it is a linear function. For inverse variation, it's always a curve, and it excludes the origin. It never goes through the origin. And it's called a reciprocal function or an inverse function. So to solve direct variation and joint variation and inverse variation problems, we will use proportions. Now remember, proportions are just two fractions that are equal to each other, and we solve those by using the cross products or cross multiplying. So here's an example. If y varies directly as x, and y is 12 when x is negative 3, find y when x is 16. So what we're going to do for direct variation, we said those are where we have y over x equals y over x, if you look at that in that table. So we're going to put the y1 that goes with its x1 over y2 with its x2. So 12 goes with negative 3. Y is 12 when x is negative 3, so those two have to stay together. And then this y goes with this x. So we're going to say 12 over negative 3 is equal to y over 16. And then cross multiplying. Negative 3 times y2 equals 12 times 16. And then dividing by negative 3, we end up with y2 equals negative 64. So I've left an example on each of these slides for you to do when you bring your notes to class. So here's another example. This is a joint variation. Y varies jointly as x and z. We want to find y when x is 8 and z is 3, if y is 16 when z is 2 and x is 5. So here's our joint variation equation. When we solve it for k, this is what we get. And so we need to just make sure we're putting the things together that belong together. The 16, the 2, and the 5 go together. and the y, the 8, and the 3 go together. So we have 16 over 5 times 2 is equal to y2 divided by 8 times 3. And then cross multiplying, we get 8 times 3 times 16 equals 5 times 2 times y2. And then 384 equals 10y2, dividing by 10, we get 38.4. So go ahead and pause the video. Go ahead and try these right away so that you can see if you're understanding the concept. Our third example here says r varies inversely as t and r, inversely as t, and r is 18 when t is -3. Find r when t is -11. Well, in this equation, when we solved it for k was equal to the product of the two the quotient of the two variables, r1 over t1 and r2 over t2. Oh, let me back up for a second. This is the product, the inverse variation when you solve for k. So we had y equals k over x, but solving for k, it's the product. Okay, so you're going to end up taking r1 times t1 equals r2 times t2. So I kind of don't like the way that this one's written. That's confusing. So just remember, I'm going to write this in here, that the constant is equal to x times y, or in this case, the constant is equal to r times t. And that's exactly what's going to happen once you do your cross multiplying here. So then we have 18 times -3, okay, r times t, is equal to -11 times its r value. Dividing by -11, we end up with r being 4 and 10/11. It's okay to write that as a decimal value. This one was written in mixed fraction form, but totally fine if you want to put a decimal there. Here's one for you to try. Pause the video and get that one done. All right, so some word problems. When a person swims underwater, the pressure, okay, in his or her ears varies directly with the depth. So we have pressure and depth that we're dealing with, and it's a direct variation equation. So the first thing we want to do is write a direct variation equation that represents the situation. Well, we have to look at the picture here to get the information we need. And we know that the pressure is going to vary directly with the depth. So I'm going to call the pressure P, the depth D, and that constant of variation K. Well, we need to figure out what that constant is. And our pressure here is 4.3, so I'm going to put 4.3 in for P. 4.3 equals that constant times my depth of 10 feet. So we can solve this and say K equals 4.3 divided by 10, which is 0.43. And then go right back to this equation right here. This is our equation, but we needed to find that constant. So our equation ends up being P equals 0.43 times D. Okay, so that is the equation we're going to be using for this problem. So it says find the pressure at 60 feet. Well, that just means substitute in 60 for P. That equals 0.43 times D. So dividing both sides by 0.43 and solving for D, if you just punch that in on your calculator, we end up with D being equal to 25.8 feet. All right, and the last problem here says it's unsafe for amateur divers to swim where the water pressure is more than 65 pounds per square inch. How deep can an amateur diver safely swim? Well, we're going to just, instead of P, we're going to put 65, and we're going to say that is equal to 0.43 times whatever depth we are at, and then dividing by 0.43 on both sides. And our depth turns out to be approximately 150 feet, if you punch that in on your calculator. Here's one for you to try. I've highlighted some significant terms for you. So your volume is going to vary inversely. So look at inverse variation with the pressure. So your two variables will be volume V and pressure P. Give that a try, and we'll see you in class.